essential question. Do all systems of equations have one solution? Well, a system of equations is two or more equations. So in the past, we've always dealt with one equation at a time, except for when we were working with parallel and perpendicular, because in order to see if lines were parallel or perpendicular, we needed two equations. That's going to be like this entire chapter. We're always going to be looking at two equations or two lines and make determinations about them. The solution to a system of equations, there could be one, none, or infinitely many solutions. So there are three different options for the number of solutions a system can have. All right. This chart is going to be really, really important for your notes in this chapter. You're going to use it not just in lesson 6-1, but the entire chapter. So if you're watching this lesson video for the first time and taking notes, I would pause right now and make this chart. You're going to really want it in your notes. You're going to need it for the homework today and in lessons in the future. All right, so if I have two equations, the most popular solution you're going to end up with are two lines that intersect. So I'll make my two lines green and blue. These lines are called intersecting lines. So pretend I had two equations, I graphed them, they intersect. When lines are intersecting, you look at where they intersect or how many times they intersect. These two lines only intersect one time, so there is one solution. Two lines can only intersect one time ever, so you're never going to have more than one solution if the lines are intersecting. For intersecting lines, the equations have different slopes. The y-intercepts could be the same, they could be different, we don't know, but the equations have different slopes. Alright, the second possibility with two equations when you graph them is to have parallel lines. Parallel lines run right next to each other, but never intersect. So we'll put parallel here. Now if you think about it, the number of solutions. How many times will this green and blue line touch one another if they're parallel? They will never, because parallel lines never intersect. They never cross over each other. They stay straight the entire time. So there are no solutions for parallel lines. These lines don't ever intersect. They don't ever touch one another. The equations for parallel lines, if you think back to chapter 4, we know that the slopes are the same, because we learned that parallel slopes stay the same, perpendicular flip and change, and they also can't have the same y-intercept. They have to be crossing the y-axis at different points. So we'll say different y-intercepts. The third possibility is to have two lines that fall right on top of each other. So I'm going to put my blue line directly on top of my green line. These lines are called identical because they make the exact same line. Now if you look at these identical lines, how many times do they intersect? Well, they intersect here, 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 and that'll keep going forever. So they intersect an infinitely many times. Now think about the equations. If we have the exact same line, they have to have the same slope and the same y-intercept if they're going to be exactly the same. Alright, name two lines that make a system with one solution, no solutions, and infinite solutions. Okay, so one solution, let's go back to our chart. One solution is right here, and we need the lines to be intersecting. So let's look for lines that are intersecting. We actually have two different options. We have our green line, which is y equals negative 3x, oops, I did two negative 3x, negative 3's there, minus 5, and our red line, which is y equals 2x plus 2, or we have the green and blue. So the green again is y equals negative 3x minus 5. And our blue is, well, there's actually two equations with our blue. I'll take the slope-intercept equation, but both would be right, 2x minus 5. Okay, no solution, if I go back a slide, no solutions are parallel lines. So let's find some parallel lines. It looks to me like the red and blue are parallel, which our red is y equals 2x plus 2. And our blue, again, has two equations that go with it, but you can write either one. Now, infinitely many, go back a slide again, is identical. So two equations that make the same line. Now look for the only equation that has two, or line that has two equations attached to it. If you look at the blue line says this equation and that equation both make up that line, and I'm going to show you how that works in a second. But our blue line, which is y equals 2x minus 5, and 4x minus 2y equals 10. Now you might be wondering, how can those be the same line? Well, let's see what happens if I take 4x minus 2y equals 10 and get it in slope-intercept form like my other equation. So I'm trying to get y alone, so subtract 4x on both sides. And then I'm going to get y alone by dividing by negative 2. This is a heart problem. So negative 4 divided by negative 2 is 2. 10 divided by negative 2 is negative 5. Now you'll notice this equation and this one right here are exactly the same. So that's why both equations make the same line. One is just in standard form, the other is in slope-intercept form. Okay, identify the following in each system: the number of solutions, the type of lines, and if they intersect, name the coordinate. All right, so we need y equals negative 3x minus 5. Which is this line right here. And we need y equals 2x minus 5, which is this line right here. Okay, so what do you notice about this line? How many solutions does it have? Well, it intersects right here. So there is one solution. Then it says the type of lines, well, they're intersecting. And then it says, if they intersect, name the coordinate. So we need to name that coordinate point. Now remember, we always go left or right first. So we went left or right 0, and then we went down 1, 2, 3, 4, 5. So my coordinate point is 0, negative 5. All right, this time we're looking at 2x minus 5, which is this line right here. And we're looking at 2x plus 2, which is this line right here. Now these lines are parallel. Parallel lines do not touch or intersect at all, so there are no solutions. And we don't have to name a coordinate point this time because there aren't any solutions, there aren't any coordinate points. You only name the coordinate point if they intersect. And now we've got 2x minus 5, which is this one right here. And we've got 4x minus 2y equals 10, which again is this one right here. So these, since I drew the same line twice, they are identical. When lines are identical, there are infinitely many solutions. again, we don't need to name a coordinate point because they're not intersecting. If I wanted to name all the coordinate points where these lines intersected, I would be listing off coordinate points forever and ever and ever and ever, because these lines continue forever and every single coordinate point is a solution. Alright, identify the following in each system. Alright, so 3x plus y equals negative 5. Now I'm looking at my graph and I don't see that equation over there. So that must mean I need to get this equation in slope-intercept form. So I'm going to try to get y alone and subtract 3x on both sides. This is what I did earlier on that other problem. Now remember, we can't combine negative 5 and negative 3x. We have to keep them separate because they're not like terms. Now let's see if I have a line that looks like that equation. Yes, I do. It's right here. And the bottom one, negative 2x plus y equals negative 5. I also don't have that equation. So I'm going to try to get y alone here as well. So y equals, and again, keep the 2x minus 5 separate. Now let's see if I've got that one. Yep, I do. It is right here. So this one is the same one we used earlier, which it had one solution. It was intersecting. And then the coordinate point where they intersect is right here, which we said was 0, negative 5. Summary. The homework for this lesson is page 336, numbers 1 through 6, 10 through 15.